Section 1.6 talks about complex analysis, or complex numbers I should say. So we define the square root of -1 to be I, and if you square both sides, I squared is -1. A standard complex number, normally we refer to it as Z, is given in the form of A plus BI, where A and B are real numbers. So first I want to make sure that you're comfortable with this notation. Now, when would you know to get an I and when would you know to give no solution? Because the square root of a negative has no real solution. If a problem says find all solutions, then you would actually list the I. If it says find real solutions, I would be, whenever you get an I or a square root of a negative number, you would say no solution. And if you mix those on our exams or quizzes, not a problem. That's no big deal. Right? Unless the problem says find all solutions, I want the I in there. But if you're supposed to say there's no solution and you give me I as a solution, that's acceptable until we get the hang of this. So example 1 says, find the real and imaginary part. Again, remember A plus BI. A plus BI, in which that's a number and that's a number. Both of those could be any real number. So if I match this, well, the real is A. This is the real. And even though B is a real number, but that deals with the imaginary part. So what's the real? The real is 0. And the imaginary number would be in the -7. In question B, I would split this up because I always want it to be in the form of A plus BI. This would be the real, and the -8/5 would be the imaginary. If I look at C, I'll notice something's missing. That's a different type of problem. Well, that's because this is -2 plus 0i. So if I say what's the real, you would say that's -2. And if I was to ask what's the imaginary, you would say it is 0. And similarly, by glancing at D, you could think of that as 0 plus 3i because 0 is a real number. So real will be 0, and the complex or the imaginary part, let's stick with the book, imaginary. The imaginary would be the 3. E, I need to modify it a bit, that's 5. So this is the deal. Before you do anything, anytime you see a square root of a negative, you put an I before you proceed. And what do you multiply by itself to get 9? 3. So here the real would be 5, and the imaginary will be a -3. So what are we going to do with those? It's fairly simple. We're going to just apply algebra to those, how to add, subtract, multiply, or divide. Well, if we add them, you treat I in any kind of calculation like a variable, like an x. So you could think of this as saying 2 plus 4x plus 2 minus 5x. Same as any other operation. 2 plus 2 is 4. 4i minus 5i is -i. The crucial part, you take any complex number, add it to a complex number, you get a complex number. You multiply two complex numbers, you get a complex number. You divide them, you get a complex, and you multiply them, you get a complex. Not only that, if you raise a complex number to any power, that's the key, you get the same complex number. That's not for this class, but we will touch on that slightly. The opposite of those will be -2 plus 3i and that would be a -5. So it's a good habit to get into writing the part without an I first and the part with an I after, even though it's not wrong not to, but you know, just to keep the same format. kind of like when you say 3x, you don't say x3, you could, but normally we write 3x. Again, the opposite is a negative 4 minus 7i. That would be a negative 4 minus 3i. So this section is straightforward for the most part. How about if you multiply? Well, that is, again, you treat that just like you treat an x. Done. Six I plus 9i squared. And remember, you only need to memorize that the square root of negative 1 is I, and I squared is a negative 1. So that becomes a 9 plus 6i. And if I FOIL, 2 minus 2i plus 3i minus 3i squared, 2 minus I, and I squared is a negative 1, so 3 plus 2 is a 5 minus I. Same thing if I wanted to FOIL, that is the first squared plus 2ab, 2 times the product of those, plus b squared. Of course, you're welcome to write it twice and try it the same way. And when you square the last, that's 4i squared. So that's a 1 plus 4i plus 4, and the I squared is a negative 1. So that's negative 3 plus 4i. And if I wanted to divide, there's one catch. You gotta remember, I stands for a radical, and I can't leave a radical in the denominator, so I need to rationalize. If you multiply by I, and the reason you're going after I, because you know that I squared is a negative 1, so that would be simply negative 3i. So you only need to remember the original definition, which is square root of I is negative 1, and negative 1 is I squared. Here, again, I've seen this before. This is dealing with two terms. I would think of a conjugate. So I would multiply by the conjugate of this. Okay, I did say conjugate, but I didn't write conjugate. So the top would be 3 into 1 minus I. The denominator will be the first squared minus the second squared. That will be 3 minus 3i. And this will be 1 minus a negative 1 is plus 1. And I would write this as 3 halves minus 3 halves I. That's how the author will write it. It's a good idea to get into that habit, because that's really what we need when the time comes. And if I look at this problem, again, same deal. I multiply by the conjugate, which is 2 plus I. So if I multiply the denominator out, that's the first squared minus the last squared. But I know that this is negative 1. So 4 minus a negative 1 is a 5. Denominator is done. The top, if I FOIL, I'll get 4 plus 2i plus 6i plus 3i squared. That would be, I know that's a negative 3 because I squared is a negative 1. So negative 3 plus 4 is a 1. And 4 plus 2 is 8i. And that would be 1/5 plus 8/5 I. So you notice, whatever you do to a complex number, you get it in the same form, a plus bi. That's not true for other numbers. Here I would have to really work out each of those and say, well, alright, I'm gonna make some space between those, so just to save space in the notes. So remember those where you're subtracting those, what you do, you rationalize each. So the first denominator is 4 minus 9i squared. That's a negative 1 times negative 9, that's positive 9, that's 13. Whatever you multiply the bottom with, you multiply the top with, a ratio of 1 if you remember. 4 plus 6i. So this is 4 plus 6i over. And I multiply this by 2 minus 3i. And that would be, the denominator will be a 4 minus 9i squared. The same deal, that is a 13. There's a minus. And if I distribute that in, that's a 2 plus 3i. So, since they both have the same denominator, I could simply combine them into 1 and say all over 13. That's going to be 4 plus 6i minus 2 minus 3i. That would be a 2 plus 3i over 13, or 2 over 13 plus 3 over 13i. The next problem up, again, I have an option, couple of options. I could multiply those. I could say, you know what, that's the square root of negative 3 times negative 12, which is the square root of 36, which is a 6. Not allowed. You're not allowed to apply any operation on reals. That's for real numbers. The first thing you do, you write this as radical 3 and you tag the I up front. And the first thing you do, you write that as 12i. Once you do that, you say, okay, now I know what to do, because radical 3 times radical 12 is the square root of 16. I times I is I squared. Oops, did I say 16? I meant 36. And you know this is negative 1, you know that's a 6, so the answer is not positive 6, it's negative 6. So anytime you see the square root, if you want to play it safe and there's a negative underneath, I suggest that the first thing you do, before you do anything in your head, put the I outside of the radical. Basically what you're doing is saying that's the square root of that's the square root of 16 over 9 times the square root of negative 1. That's the I. Do that first, and then you won't get it wrong. And now you could simplify this, whether it simplifies or not. It is 4/3 I. And if I look at part N, the same deal. I look at this before I proceed. The top will be square root of 36i. That would be radical 2i, and that would be radical 9i. So a couple of ways you could do this. You could cancel those i's. You could say this is, one option is to say, you know what, that's the square root of 36 over square root of 18. I. Rationalize. That would be the square root of 16 over 18 I over I squared. That is, I'm so stuck on 16. I don't know why 16 is stuck in my head. And 36 divided by 18 is a 2. That's a negative and an I. And you're done. Or, you could say that's the square root of 36, which is 6 over radical 2 times 3i, right? And even though I'm supposed to work downwards, I'm going to work sideways. You know what? I could have did that sideways. That's fine. Let's do that, so that nobody's confused. Let's run this one more time. So, one option. Option 1. I could say this is the square root of 36, well actually, yeah, that's okay, over radical 18 I, which is the square root of 36 over 18. And if I rationalize, I get I over I squared, and that would be a radical 2, that's a negative, and an I, and I'm done. Or the traditional way of doing things. Traditionally, this is how you do the problem. You would say that's a 6 over radical 2 times 3i. Those divide, so that's 2 over 2i. Two things are happening here. One, you're getting rid of the radical, and secondly, you're getting rid of the I. So that would be a 2 radical 2 over 2, I squared and an I, which would be a radical 2, that's a negative 1, and that's an I. So either way you get the same answer. And the last part of the solution, find all solutions of the equation. Well, that doesn't factor, but if I use the square root property like we did, every time you square root you pick a plus or minus. There's an I for the negative, radical 5, and radical 4 is a 2, and there it is. So, a polynomial has an equation in R, guaranteed. I'm sorry, in C, which is complex numbers. Unlike reals. Here, apologies. That's what I meant. So, solve, you would factor, isolate the name by itself, just like we did. Factor y cubed out, you have y squared plus 9 equals 0. So either y cubed equals 0, which means y equals 0, or y squared plus 9 equals 0, which means y squared equals negative 9, and y would be plus or minus 3i. And what if a problem doesn't factor? That happens. We know how to complete the square or use quadratic formula. Move the 5 over. Take half of the middle number, which is 3/2, and square it. So this becomes x with that sign. The number before you squared it is squared. Of course, you're welcome to use a quadratic formula. For negative 20 plus 9 is negative 11. When you square root both sides, you will get x plus 3/2 equal plus or minus an I, that's radical 11 over 2, and if you move this over, x would equal negative 3/2 plus or minus radical 11 over 2. If you want to combine those, you can, but that's normally how we leave the answer. And that's pretty much it for section 1.6 or complex numbers.